So solving through simultaneous equations, right? It looks to be very tricky, but it is very straightforward. Let's say this is equation number 1, this is equation number 2. Okay. Now step 1, choose a variable to eliminate. Choose one variable to eliminate x or y. So let us say I've chosen x. Okay. Now step 2 is check the coefficients of the chosen variable. In this case, it is x. Are they equal? If not, most of the times it is not, because that is why you're doing simultaneous equations most of the time, because to make the subject more tricky. In this case, you have the equation number 1 has the coefficient of 1, and equation number 2 has the coefficient of 3, right? Now what you do is you multiply, you do the crisscross multiplications. You multiply 1 here and you multiply 3 here. So let's do that. So if I multiply equation number 1 with 3, so this becomes what? 3x, and then plus 3 times 2 is 6y, equals to 3 times 8 is 24. And you multiply equation number 2 with 1. So obviously it is 1, so that will remain unchanged. So 1 times 3x is 3x, 1 times negative 2y is 2y, and then 1 times 4 is 4. Now the idea behind doing this is that whatsoever you are chosen to eliminate, their coefficients should be exactly the same. So this multiplication has now made x, which was your chosen variable, exactly the same coefficients. Is this clear so far with me? All right. Step number 3. Once the variables coefficients are equal, now check the sign of both, basically both variables in both the equations. Here my 3x is a positive 3x, and the bottom equation has another positive 3x. So for the sake of simplicity, I call this as equation number 3 and equation number 4. So equation number 3 has positive 3x, equation number 4 has positive 3x. So same sign. When you have same sign, then you subtract 4 from 3. If you have opposite signs, so that means, let's say you have a plus 1 in equation number 3, you had a positive 3x, suppose, and you had a minus in the bottom equation, equation number 4. In that case, you had opposite signs, so you would have added the two equations. Now, in this case, we've got same sign, so we are going to subtract 4 from 3. So let's subtract 4 from 3. My equation number 3 was 3x plus 6y equals to 24. 3x minus 2y equals to 4. Now I'm subtracting. So whenever I subtract, so this was equation number 3, this was equation number 4. So whenever I subtract the bottom equation, I will always flip the sign. Why? Because I have a negative. So this 3x positive becomes negative 3x. This 2y negative becomes a positive 2y. And this 4 positive becomes negative 4. Now this is very, very, very important step. 99% of the students fumble when the signs are same and they are subtracting. They fumble because they don't flip the signs correctly. You just have to see this bottom equation and carefully check the sign, ignoring the top equation. So this is as good as if I were to do it algebraically. This is what I'm trying to do. Equation number 3 minus equation number 2. 24 minus 4. Now this minus is actually, when I open the bracket up, it is going to flip the sign. No, you see, 3x positive become a negative 3x. And this negative negative becomes a positive 2y. That is why there's a positive here. And you've got a minus 4 here. So that's the logic behind flipping the sign. All good with me so far? All right. Now, let's see. Let's do the subtraction. 3x positive. Now this is a negative 3x. Gone. Eliminated. Finished. 6x. It's not minus 2y now. 6x plus 2y. It is 8y. And what is this? 24 minus 4 is 20. So what is y? Y is 20 over 8, which is 5 over 2, if I divide it by 4, right? That's the value of y. Now, once I've got the value of y, I can sub this value of y into any of the equations, either 3 or 4 or 1 or 2. For simplicity, I will always consider 1 or 2 because their coefficients are the simplest. So I'll say x plus 2y equals to 8. So x plus 2y was 8. My y is 5 by 2. So x plus 2 times 5 over 2 equals to 8. 2 cancels. This becomes x plus 5 equals to 8. X equals to 8 minus 5, which is 3. So x equals to 3 and y equals to 5 over 2. Now let's quickly take and extend this to do this particular stuff as well. Same, where the signs have been opposite. Now for the sake of simplicity, let's pick up this equation again. X plus 2y equals to 8, and we'll solve it again, right? X plus 2y equals to 8, and the other one was 3x minus 2y equals to 4. 3x minus 2y equals to 4. My step 1, choose a variable. Let's say I choose y this time. Okay? Step 2, check their coefficients. See, just check the coefficients only, not their sign, the value itself. 2, 2. Since they are exactly the same value, I don't need to multiply. If they would have been a different value, I would have multiplied it the way I've done it here, right? So no need to do that. My coefficients are exactly same. So same. Step 3, check the sign, opposite sign. Now I will do, what was my step 3? I was supposed to add the two equations. Let me add the two equations. Let me just write it down and add the two equations. Adding is very simple. It does not, you don't have to, change signs. X plus 3x is 4x. 2x plus 2x minus, gone. That is why you added, because they were opposite signs. If you would have subtracted, this would have resulted in the same sign. Then you could not eliminate them. And this 8 plus 4 is not, 8 plus 4 is 12. Sorry, my bad. I subtracted. So x equals to what? 12 divided by 4. X equals to 3. So I got the answer as x equals to 3 now. So it is adding, no? All addition. Now my x equals to 3. You see, I got the same answer as here, x equals to 3. All right. So in its simplicity, this is how the simultaneous equation are dealt. And you need to take a note of all these steps, and then you can do any simultaneous equation in the world. All right, cool. Thanks.